everyone. So I'm going to be talking about how, when you're making your MCP servers, how you can improve your tool schemas to make them more reliable when agents use it. And my name is Pamela Fox, and I'm currently at Microsoft or GitHub, whichever one you like the most. I apparently work for both companies now because we got reorged a couple weeks ago. So yay! Now, since it's that's like a very serious-sounding talk title, but let's start off with something more fun. So the question is, can we use MCP to design our outfits, right? Which is like very important to be able to do. So here I've got VS Code open. It says, oh, I'm presenting at PyAI about MCP. Do I have any MCP clothing, right? So it does a little search, right? So it searched for, it even knows, it expands MCP, model context protocol themed clothing. It found back a bunch of image results, so you can send back binary from the MCP server. It says, yes, you do have an MCP themed dress. You down with MCP? Yeah, you know me. And so it shows me it. And this is an MCP app, so we can render an MCP app to show as like a little gallery. And I'm like, okay, great. Love the pink, matches Pydantic AI. Can we get some accessories? Like, okay, you got this. Okay, looking good. And I said, all right, I also need a jacket. And it's like, all right, and now show me my complete outfit. We got the dress, the jacket, and the earrings. Boom. All right, so that's kind of a fun thing that you can do with MCP, and also shows the fact that MCP servers, they can return more than just text. They can return images, binary, and they can return apps. So you can have these actual interactivity there, and you can start thinking about what more you can build with MCP. Now, this will fill up your context window quite quickly if you start doing a lot of searches in your closet, depending on how many options you have, but it's pretty fun. Okay, so going back to what we're actually going to do. So first, let's build a just basic MCP server with Python. What does it look like? Here is a FastMCP server. We've got, this is for adding expenses to a database. So we've got a date, we have an amount, we have a category, and we do description. Most of these are strings, except for the amount, which is a float. And so what happens is that those tool parameters, they become a JSON schema. So FastMCP automatically turns that into a schema and then sends that down to the LLMs. And that's what the LLMs see and how they decide what they're going to do with it, right? And a lot of times that's what I see people start off with when they're building these servers, is these kind of like bare types, right? Now the thing is, most of the things are strings. So if you tell it like, oh, you can just put any sort of string in there, right? So here, if I say like, okay, I bought a $12 chocolate bar yesterday at Dandelion, and I give it that server, it's just gonna, it's gonna decide, all right, this is what I think the date should look like. This is what I think the category should be, description, right? So the LLM's going to decide how to fill in those arguments. And without any constraints, it can be very, very creative, right? So this is for category. I ran it 83 times to see what it would come up with, multiple languages, Spanish, whatever. And we got a wide range of categories, right? And that can be good, but a lot of times you do want to, rein your LLMs in. You want to constrain the schema more to have more predictability in the way your tools are getting called. So there's many ways that you can constrain the arguments when you're building these FastMCP servers. The first thing that I have to beg everyone to do is add a description to your fields, right? So instead of just saying it's a string, you say annotated string field, you give a description, and you say, hey, this is a string, here's the description of this, now you understand what this argument is, right? Because otherwise it literally is only going to see the name and the type, and that is not enough information. So you have to add a description, right? So start off with that, and so then that description gets added to the schema. The next thing we could do is we can actually constrain types, right? We could use a literal type from Python. We could say, hey, this thing can only be one of these, these types here, right? And so that then becomes this list in the JSON schema. And so the LLM says, oh, okay, I'm only allowed to do that. And best if you do both, right? You say, hey, here's exactly the types you're allowed to choose, and here is your thinking process you should use when trying to decide which of these types you're going to use. So those are some options. So here's the question. I try to do this as this is like a research talk. I'm not a researcher, but I cosplay. So do agents actually like stricter schemas, right? My theory, my hypothesis is that they would, and that's how I wrote my abstract. But I have to evaluate and actually find out, right? So I set up a Pydantic AI agent and pointed it at my MCP server. And I was like, okay, you're going to help users log expenses, and here's today's date, right? And then I wrote all these different tools with different schemas. So all the schemas I showed you, I wrote tools with all those different variants. And then in the agent code, I can just filter it down and say, hey, agent, you're only allowed to see these variants right now. So that way I could mix and match and see, okay, the agent with these variants, what does it decide to do, right? And then I set up a bunch of evaluations. Now, the funny thing is, I thought I used Pydantic AI evals for these evaluations because I totally asked Copilot to do that in my plan. And then I was looking at it yesterday and I was like, oh my God, it just wrote its own evaluation framework. So that happens, and like that works too, right? That's fine, right? So yeah, it just came up with an evaluation framework that looks similar to Pydantic AI evals. But basically I just set up all these cases and say, hey, you know, this is the prompt, this is the category I expect, this is the date I expect, and here's the amount, right? So, you know, came up with lots of different variations, different languages, et cetera, to, you know, try and trick it. Then I run all the evals with a certain model. I set the seed for the models that support it for better reproducibility. I set the temperature to 0 here to make it less creative. And then, you know, output all those results in some JSON and also a markdown. And then I ended up just working with a coding agent to say, hey, all right, here's my results. Can you help me just muddle through them? Because even with a human readable report, I got tired of reading those reports. And I was like, can you just look at the report? Like, this is like the 10th report I've seen. And that was helpful for me. All right, so I ran the schemas. So I compared having a string with a description, having a literal, having an enum, and then having the enum with the description. So I looked at, was the tool called at all? Because the thing that's interesting that happens a lot is that it doesn't feel like it has enough information to even call the tool, and it like asks a clarifying question, says like, I don't feel empowered enough to make this decision. So that's, you know, the first row is, was the tool called at all? You can see with just the description, it was only 15 out of 17 times. And then when it was called, did the category match the one we expected in our ground truth? So I set up all this ground truth and said, hey, for this prompt, I expect this category, right? And then I also looked at how big the schema is, because everything's about trade-offs, and the more you add to your schema, the more constraints you add, the longer description, that's going to add, you know, more tokens. So for example, you can see this question here, the day after tomorrow, I will buy a bus pass for $20. With only the description, the agent says, hey, could you please specify the category? It just didn't know. Once we had both the enum and the description, it was like, okay, cool, transit and fuel. So we kind of like, by doing the enum, it basically forced the LLM to be like, okay, well, they really, really want me to pick one of these categories, I'm gonna do it. That's what it seemed to like kind of empower it. And then when did category match improved, right? So, you know, we can say like, okay, I paid $99 for an app. When we had a literal, it became apparel and beauty, which is funny, app, apparel, I guess. And then when we gave it more of a description, then we got, you know, correct electronics and tech. So it's interesting to see when you run these evals, like the kind of failures you see and what things get better when you do. So what you generally see is that, yeah, as we added both a description and an enum, we did get what looked like, you know, much better results. We also had a much bigger schema size. So you do need to like keep that, you know, trade-off in mind. But it looks like evals are better. Now I wanted to look at one more schema variant here. So the date field. Now I thought date was interesting because I set it as a string. I could also do a string with a description. I could do an actual Python date type, and that becomes a format date in the JSON schema. And you can specify regex patterns. That's another way you could do it. So any of your MCP like arguments, the tools could actually be defined as a regex, and you can tell the LLM like, hey, your answer has to match this regex. And it's always fun to try and get LLMs to adhere to regexes, right? So that's what I decided to try. And the thing that was fascinating is that I got the same results across every single schema, including the one that didn't even have a description. So I didn't even tell it that I wanted it to be in year, month, day format, and every single time it gave it back as year, month, day format because that's the ISO 8601 or whatever, right? So without even a description, and this is like, it infuriated me so much because I'm like, no, the whole point of my talk is to show people that you should have stricter schemas because you're gonna get way better results. But then I ran the evaluations and was like, okay, well, as it turns out, LLMs are really good at just assuming that if something is called date, that you want it in like standard date format, and they will just give that to you, right? Now, it was still interesting to see the places where they failed, because they all failed at the same thing. And these were still interesting to run, because I was running these right around February 28th. And there's no February 29th this year, but only some of the models know that. And this is GPT-4.1 Mini. GPT-4.1 Mini couldn't work out the fact that there was no leap year this year. So it kept saying, February 29th. I'm like, that doesn't exist, right? So it is always really interesting to see the ways in which your LLMs will fail to call tools. In this case, the schema made no difference. I still learned interesting things about the way kind of mishandled date calculation and made up dates that didn't exist. But yeah, the schema didn't make a difference. However, it does make a difference for your code, right? It's nice in Python when we can use types, because we can use them in other places too and be like, okay, this is the type we expected. All right, so then I wanted to run some more evals, right? So one question was like, okay, that was all with GPT-4.1 Mini. We've all moved on past Mini. We're over it. Do all models think alike? What if I run it with others? So I did it with 4.0, 4.1 Mini, and 5.3 Codex. I even did it with 5.4 a couple days ago too. 5.4 is quite good. So then I looked at the stats, and generally what we see is interesting. It's actually different across both of them. So for category match got worse for 5.3 Codex in terms of matching my ground truth. It just disagreed with my ground truth. And maybe 5.3 Codex is just smarter than me, and I should just change my ground truth to match what Codex thinks. But then with 5.3 Codex, the date match there really improved. And that's where is because 5.3 Codex is just better at, we'll say math. Not that LLMs can do math, but it didn't make the mistakes with mistakenly doing New Year and how to calculate 2 Mondays ago and stuff like that. So that was pretty interesting to see, is that, for something like date calculation, we do see much better with the new models. For something that's a little more wishy-washy, okay, what category is this? Sometimes these newer reasoning models will disagree with you and come up with something else. So you can see some examples here, a spa treatment. Is that health and fitness or apparel and beauty? Maybe that's just too ambiguous, right? So sometimes when you run evals, you look at the results and be like, you know what, maybe I should change my, the data I'm running it with. Maybe this data is actually ambiguous and I should be changing it anyway. Because it's too hard even for a human to decide, right? Maybe some of you think that, maybe some of you agree with the failures here and think that those are the right answers. So it's just every time you run evals, you learn something. Now I wanted to try the reasoning models on different reasoning levels, because whenever they come up with reasoning models and they're like, oh, okay, and you're like, great. What level do I use it at, right? Do I use it at low, medium, high, X high, right? And people on Twitter are like, oh, you got a code with 5.3 X high, it's the best. I'm like, okay, I'll try. So that's what I did. So I looked at 5.3 Codex from low to X high, and as you can see, it did the best on low. In terms of my category match heuristic, right? And once again, just as soon as it started thinking about things, it started overthinking to the point of disagreeing with what I had put there, right? And once again, maybe some of that overthinking, actually, maybe it was thinking even better than me, and so I could go back and look. But there's definitely an effect that the reasoning has on this selection process. So it is worth looking at what happens when you give these models the ability to think more. And of course, the latency goes way up, right? From 7,000 up to 12,000 milliseconds. And that's always a thing you have to think about when you're deciding whether to do reasoning. Okay, so next I was like, all right, so we looked at models. What about agent frameworks? Everyone's trying to decide what agent framework to use. There's so many of them, right? Developers are constantly asking me that, right? Obviously, since we're at the PyAI Conference, I'll tell them to use Pydantic AI, but at each conference, I'll just give a different answer, whoever pays me. So, also, since I said I work for Microsoft GitHub now, my GitHub, whatever. So I did use the GitHub Copilot SDK. So I set up a Copilot SDK agent with the server, and to try and same prompt, same server. And the only thing that's different is whatever agentic loop is inside this agent framework, right? And they do have some subtle differences in the agentic loop sometimes, that can affect these things. And so then I looked at the comparisons, and as you can see, actually, they got exactly the same numbers. So they have either really similar agentic loops, which is very possible, because basically what is an agent? It's tool calling in a loop. This is just a fairly deterministic thing. Actually, I have to say, I did have to rerun these numbers. Okay, I'm like making Copilot look good here, because originally it failed on almost all of the date cases, because I ran the eval first at 9 p.m. Pacific time, and it got every date off by 1. And I don't know why, because in my prompt, I told it what time it was on my machine. I think that there's some, because GitHub Copilot kind of has its own system prompt too. I think there might be a system prompt like inside that agent runtime that has a UTC time instead of, so luckily I woke up at 3 a.m. And reran the evals, and that time, it worked because we were the same day as UTC. So interesting things happen with date and time. Okay, so there we go. So some conclusions here. I originally thought the conclusion was going to be that structured schemas definitely make agents more reliable. And a year ago, I think that would have been true, because this was all based off of errors I was seeing originally with MCP servers that didn't have structured schemas, and the LLMs weren't doing a good time calling them. But now the LLMs are so good that that it doesn't really matter that much as long as you give it enough of an idea of what you're looking for. But there's still a lot of benefit to structured schemas. We did see slight improvements in agent reliability, but it just means you have more type-safe code, right? And you're able to better reason about your code. You get better validation, ID auto-completion, fewer runtime errors, right? So even if the structured schemas, don't actually improve the agent reliability, I think it's often worth it to do it. But of course, the only way to know is to do evals, as Hamal says. I have your tweet here, and he's got the hats for it too. So you don't really know these things unless you do the evals, and every time that I do evals, I learn something new and interesting, about the system that I'm evaluating. All right, so thank you. I'm supposed to plug Logfire. Okay, yeah. Here you go. We're got to plug everything, right? So we got Pydantic AI. Okay, so yeah, when you do Logfire, it's pretty cool. So I've got Logfire instrumenting both the agents and the tools, right? So it'd be I bought $20 of chocolate today at Dandelion. I do recommend Dandelion chocolate in San Francisco. It's so good. All right, so then that should send a call out to our MCP server, which is running over here. Here we go. There we go. That's earlier today? Let's see. Reasoning, it's got a reason about it. Yeah, there we go, reasoning. All right, it's running, and then we're gonna do just last 5 minutes. Logfire is really cool. I don't know, how many of you have used Logfire? All right, nice. It's a really nice UI. I quite enjoy using it. So there we go. So we can see we got a tool call request, right? So you can instrument your MCP servers in 4 lines of code, instrument the agent servers, and then with the Logfire traces, then you can also just point your evals at your traces too and learn from them as well. Okay, great. Plugged all the things. So you can grab my slides from here and the code from here, and I'm happy to answer any questions. Thank you, everyone.
Thank you. I'm glad to know that I can use my FSA for SPA if I use a low-thinking model. This is great. We have time for one question. Yep.
When have you seen schemas and strict validation making things worse?
Right, so also the thing I didn't mention is that some of these schemas originally completely broke models. So remember that enum I was showing? Originally enum, if you did an enum in FastMCP, FastMCP serialized it using this particular thing called like JSON schema references, and the Opus models hated it. They just would, the API would error. And so I like reported it in the FastMCP tracker, and like they were kind of trying to decide what to do, because on the one hand, they were outputting valid JSON schema according to the JSON schema spec. On the other hand, some models apparently like weren't fully compliant with the spec. So Jeremiah ended up changing it to basically inline those enums. And basically the reason enums and literals come out exactly the same is because he made it so that when you do an enum, it ends up being like this, because it's actually technically supposed to use this like whole references thing, but it's kind of like pointers in your schema, and the models were not handling those pointers. So that's like a plug for FastMCP. If you do use FastMCP, like every time I've had an MCP tool like issue compatibility, I've reported it, and a lot of times that means simplifying the schemas to work better across models and across clients, because also there was a VS Code issue too that they improved. And that's also what I talked with the folks behind the GitHub MCP server, and they've also had issues with JSON schema where they're like, oh, like models don't like if you have like this empty object, right? So so none of my examples today actually broke the models because FastMCP is like kind of battle hardened now, and people have tried it with so many different models and clients.
Awesome, thank you.